In this lesson, we're going to talk about inequalities. Remember that if you multiply or divide by a negative, you flip the symbol. Example. If you have negative 2x is greater than or equal to 6, when you divide by a negative, we're going to flip that symbol over. And so we get less than or equal to. And it doesn't matter if it has the equal to or not. If you have like negative 4x is less than 12, you get x is greater than negative 3. So just be careful that if you multiply or divide by a negative, when solving inequalities, you want to flip the symbol. Now, as we do these inequalities, there's some things that we need to talk about. A notation you may have seen in Algebra 2, but you may not have. It's called interval notation. And it shows us a subset of the real numbers. So think of the real number line. Okay, so let's say normally we would see that we want x's greater than or equal to 4. What interval notation does is it depicts what we see on the number line. So we are equal to 4, so color it in, and then greater than we would shade to the right. So think here's 5, 6, 7, and so on. What interval notation does is it specifically shows us what is showing up on the number line. So we would have a bracket indicates that that was colored in. We can use the number 4. And so if this has an equal to, it's going to have a bracket. And then this is going to the right, going to positive infinity, and positive infinity always gets a bracket. So let's say we have a just a greater than. What's the difference? Well, think about what's the difference on our number line. This time, we're going to have an open circle at 4. You might recall, open means you're not allowed to be equal to it. So our interval notation follows the number line, and it indicates there's an open circle on the 4 by putting a parenthesis on the 4, not a bracket. So that's what greater thans look like. If you have less than or equal to, let's go negative 1. We would have a closed-in circle at negative 1 and less than shades to the left. You see how the arrow here matches a less than symbol. That's one way to remember that that's a less than. If we follow the number line order, this time you go from left to right. Your number line should go from left to right. Your order for your interval goes from left to right. You start with the negative infinity and you stop at negative 1. And since I can use negative 1, I'm going to put a bracket. And then finally, if I have just x is less than negative 1, I would have an open circle at negative 1 and I would shade to the right. So my interval, it has to indicate, yeah, I start at negative infinity as far to the left as I want, but I'm not using negative 1, so that's why I put a bracket. Now, the whole number line, so if we're talking all real numbers, you would shade in the entire line. So that goes from negative infinity to positive infinity. let's say that this is what my subset look like, okay? If I have two pieces that are separated, and I want to write that in interval notation, you just write each individual piece the way that you normally would see it. So this would go from negative infinity up to -1 with a bracket. And then you just use the union symbol. That means it can be in that piece or it can be in the next piece. And then you write the next piece as you would see it in its individual interval. So I would have a parenthesis on the 0, and then I keep going to infinity. So interval notation is just a very nice way to depict the x values. Usually it's x values, sometimes that's y, the values that you have. And this just means I have everything between negative infinity to -1. It is not an order pair. It's nothing but this is my starting spot, this is my ending spot. And I have everything in between. Starting spot, ending spot. Starting spot, ending spot. And it's always going from least to greatest, okay? So that's interval notation. We are going to be using interval notation because we're trying to prepare for calculus. In calculus, we use interval notation very, very often. So let's look at an example. So if we have that a is less than or equal to -4, and we want to graph it on the number line, I want you to get in the habit to put on -4 and any value that's to the left of it, but I'd usually go just 1 to the left and 1 to the right. Because of the equal to, we're going to put a closed end dot at -4, and less than, the arrow follows the symbol, shades to the left. Now, it did not mention write your answer in interval notation or anything like that. I want to get in that habit just of doing that. So A would go from, sorry, just a sec. I was trying to put a bracket when I don't need one. A would go from negative infinity up to -4. The infinities never have a bracket because we never really reach that. That bracket indicates that we stop there and land there, and we're exactly at that value. So this means we go from negative infinity and we go all the way up to -4, and that's included. That's my closed end dot. And that's what that equal to right there tells me. Let's look at this one. It says for each value, determine whether it is a solution to this. Well, my suggestion would be, let's do a little bit of math. We don't have to. I'm going to do it both ways. So first, well, let's just do the first one. Let's just plug it in. I'm going to substitute in a y value of -7. And what they're asking is that a solution? Now, a solution means that if I use that value, it makes a true statement. So just do the math. -1 plus 4 times -7 is really -28. And -29 is less than 15, yes. So that one's a yes. And we can keep going with that very thing, but watch what happens when we solve this for y. Now, the only rule we got to remember is if we divide by negative, flip the symbol. Otherwise, just it acts exactly like any equation. So I would add 1 to both sides. So I get 4y is less than 16. Divide off the 4. So we get y is less than 4. So any of those values of y that are less than 4 would be a true statement. So is 4 less than 4? It sure is not. Is 7 less than 4? No. Is -10 less than 4? Yes. Now, you can do what I can do each time, but look what you're doing. You're having to do all those steps for every single one of those problems. Here, if you solve correctly, hopefully, for the variable, and then compare, are these values less than 4? only pick the ones that are. These ones are less than 4, so those are yeses. These ones are not, so those are no's. Let's look at example right here, this example. So it says solve the inequality for x. Simplify your answer as much as possible. I have included a number line. We are going to get in the habit of drawing it on the number line and writing the interval notation. So let me write it a little larger here so we can see it. So the first thing I would do, just treat it like an equation. Let's get the x by itself. Let's add 4 to both sides. And adding or subtracting does nothing to the symbol. It just keeps that symbol. Now the rule is, if I want my x on the other side, I can do it. And you see how the open portion of that symbol is pointing toward the x over 5. So I've seen, like in Algebra 1, where an Algebra 1 teacher says the alligator is going to eat that x over 5. And so if I turn it, the alligator still wants to eat the x over 5. So just so you know, you are allowed to turn the inequality, but if you do, the symbol goes with it. Okay. So now that division by 5 means I have to multiply by 5. That doesn't change my symbol. That's not, the only thing that changes your symbol is if you multiply or divide by a negative, or if you need to turn things. Okay, so we get x is greater than 30. So that's the inequality that you would type in for Alex, but let's do this problem together. So let's make that a 30. I'm going to do one below it and one above it using number line order. Because the equal to is not on the 30, I'm going to put an open circle, and I am going to shade greater than this way. Now let's write our answer in interval notation, because we have to practice that. We're going to have an open circle on the 30, which means a parenthesis on the 30, and we're going to keep going to infinity. Do you see how that follows the number line? I started at 30, but I can't quite get there. There's an open circle, there's a bracket, or a parenthesis, I'm sorry. And then I can go forever and ever to infinity. I can go forever and ever to infinity. So let's do one more like this. So let me write it over here. It says to simplify your answer as much, solve and simplify your answer as much as possible. So we're going to solve it for x. We're going to subtract 21 from both sides. Subtraction doesn't change our symbol. We're going to divide through by -6. Now division or multiplication by a negative switches our symbol. So I usually will highlight it somehow for myself. So because I'm a somewhat forgetful person, or I make silly mistakes, you might have noticed that. And so this just helps me to kind of catch that. So the next time I write it, I'm going to write it as a less than or equal to. So that's my answer. So let's draw the picture that goes with it. So give me 4, a number below it, and a number above it. Now it has the equal to there, so we're going to need to put a closed-in dot at 4. And then less than goes this way to the left. So we're going to shade to the left. And then let's write our answer in interval notation underneath it. So we want x's that include 4, so we put on a bracket. But I didn't follow number line order. I'm having a good day here. Okay, let's start again. We have to follow least to greatest order. The least values I can get are -infinity. Sorry about that. I have to stop at 4. That's the biggest value I'll ever get, and I'm allowed to stand there, so I put it in a bracket. That's much better. So there is a 2-step linear inequality. Now let's talk about compound inequalities. If you are trying to graph a compound inequality on the number line. I don't know why I didn't give you a number line there, or I kind of did. Whether you, okay, we'll figure it out. But the word or means that you show all pieces. Whatever you get, you get. Okay, so what does that mean? Okay, so let's get our number line here. So put them in least to greatest order. Okay. And if you want to show all the numbers between 4 and 7, you can. It doesn't matter. Now, this first piece says I want the 4s that are the numbers that are less than 4. So put an open circle at 4 and shade everything to the left. But then 7 has an equal to on it, so put a closed circle on the 7 and shade to the right. So if I were to ask for the answer in interval notation, you can put on your little infinities if you want, and then follow the number line from least to greatest order. So we're going to go from negative infinity and then stop just before we get to 4, and we indicate that with a parenthesis. And then we have a little gap. So the U's are kind of, I think of as my little, oh, there's a gap there. I need to jump across that gap. And then the next number I get to is 7. I'm allowed to stand on 7, so I'm going to use a bracket. And then I'm going to keep on going. Now that one was already solved for us. The next one still says an or. It is going to be showing up on our number line exactly like this one. But we need to solve each piece individually. So I'm going to write down each piece over here. And then let's solve each one, okay? So this one, add 2 to both sides. Divide by 2. Okay? So I just added 2 to both sides, divided off the 2, and that's what I got. Here, we're going to subtract 6 from both sides, divide by 2. Okay. Now, I'm going to graph it on the number line, but then I'm also going to give you the interval notation, but just because we got to practice that. Okay. So less than or equal to negative 4, I'm going to put a closed dot, shade to the left. It's heading to negative infinity. For greater than 6, I'm going to put an open circle on the shade to the right. It's heading to positive infinity. So my interval of least most value is negative infinity. I stopped at negative 4. I'm allowed to stand there. It had an equal to, so put a bracket. And then we have our union symbol because there's a little gap there, and I need to indicate that I can have this piece or I can have that piece, doesn't matter. My next piece almost starts at 6 and then can keep going to infinity. So there is an example of a basic compound inequality with an or between it. Now, an inequality like this one just has multiple steps to take. This is our last one, okay? So let me write it over here just so we have it a little nicer to look at. And then let's think about what we can do. Well, we just, like an equation, let's move things around. Let's subtract 2w from both sides. So that'll get my w's on the left, and then let's add 25. That'll get my numbers on the right. And you could have done it slightly differently, but that's what occurred to my brain at this particular time. And then 17 plus 42 is, I said it, I'm sorry, 17 plus 25 is 42. Now we're not done until we divide by a negative, but what rule do we have to remember? Well, when we divide by a negative, we're going to flip that symbol. So again, I like to highlight that to remind me to not forget. Okay, so I get W is less than -7. Now it just says to solve it, simplify your answer as much as possible. So I'm assuming that's what they want you to put into Alex. But if you were to graph it, you would have an open circle at -7. You would shade to the left. If you were to give the interval notation, we are the leftmost value is -infinity. The rightmost value is -7, but I'm not allowed to be there, so I'm going to put a parenthesis. So that's everything we need to know right now about inequalities. There might be some other things that come up, and what they do, we'll go over those things. But this should hopefully be something you at least were introduced to in Algebra 2. Now, your homework follows right underneath it. There's some number line and interval notation that they want you to use. And then there's some inequalities to solve. Do you see how, please, it says to graph it? And it says include the interval notation. So you might get to the point where you get x is greater than 7. Put that on the line and then also write the interval notation. Okay, and so that is your 2-7 homework. So now you need to work on that. So there you go. Thank you so much for watching. Bye.